Right, MCQ 25, looking for an amide structure of C3H7CONH2. So again, let's just draw out the Vesper structure. So we're going to have 3 carbons for the C3H7. We're going to have a double bond O, and our N is going to end off with 2 of our hydrogen here. So the amide group is actually seen as a CON and a H. This will be part of my amide linkage that's actually found there. So looking for statement about this amide that's considered to be correct. So first statement over here, we're having it assumed to be a propanol amide. So again, a prop indicate a total of 3 carbons to be found in this entire structure. But again, counting out the carbons, we have 1, 2, 3, as well as 4. This should be a butane amide, alright, rather than a propan amide. So in part B, when heated with sodium hydroxide, it will form sodium propanoate. So with that, for part B, we're going to have the presence of sodium hydroxide, and this will initiate basic hydrolysis. So again, doing a little bit of the split over here, we'll end off with a butanoic acid and the presence of ammonia. But because this is a basic hydrolysis in the presence of excess alkali here, we're going to have a neutralization event to have us end off with a sodium butanoate, because this is a 4 carbon carboxylic acid salt. So no go for option B. So for option C, with sulfuric acid, this is going to be an acidic hydrolysis. So again, the cut itself will get us a butanoic acid together with ammonia. However, this time around, it is the presence of the excess sulfuric acid that causes the ammonia to go for neutralization. So it will actually form ammonium, NH4 plus, just going to put a bracket 2 with our SO4 2 minus anion. So they mentioned it will form butanoic acid. This is true because the 2 products here, one of them is going to be an ammonium sulfate, the other product will be a butanoic acid. It cannot be neutralized, butanoic acid cannot be neutralized by sulfuric acid. So for option D, it can form butanoic acid and ammonia at room temperature. So we're looking at it just spontaneously going through a hydrolysis event to break into butanoic acid as well as ammonia. Now this is going to be extremely unlikely to happen because of the stability that is conferred by the amide bond. So at RTP, this is going to be unlikely to happen. Right? Again, amide linkage increases the thermal stability of the compound. So option D will be removing. We're going to left off with option C.